free to take off with your presentation. Thank you.
See, can you see that?
Yes.
Yes.
Okay. So tonight I'll be talking about observing the spring sky, and I'm also going to cover a couple unique astronomy topics that you guys might not know about, but I think everybody needs to know about at this point. So, oh, it might take just a moment here. Let's see. Wow, this is spinning.
Is this the video you mentioned?
No, it isn't. I'm wondering if I should just do it from the slides. Would that, just so we can get going? So
Yes, that'll
would that
work.
bother slides? Let's do
No.
that because you can't see it?
No, it's great, Susan. And once you get into it, maybe you can switch over. Maybe it'll be more happier or something.
Okay, because I do have some videos that I have to call out to YouTube for, and that does get slow. So I don't necessarily want to do that to people. So, but you can see this okay, you're saying?
Yes.
Okay. So first, I'll just give you an overview of what I'm going to talk about. I'll tell you a little bit about me. Talk about what's in the night sky right now for spring. I'm going to tell you a little bit about what you can see with the naked eye versus binoculars versus a telescope. Tell you about the astronomy clubs in the area so that if you might be interested in getting binoculars or a telescope, you might want to visit one of the clubs and see what the members there have and talk to them. And then the two big things I wanted to talk about was light pollution that's getting really bad. And part of that is due to standard lighting in our cities. But the other big one is Elon Musk's Starling satellite network that he's putting up. And I don't know if everybody really understands how bad that is. So a little bit about me. I actually grew up in Washington, D.C. I was a major astronomy geek. And you can't really see you can't see much of the night sky in Washington, D.C. That didn't deter me. I built from scratch a 6-inch diameter Newtonian style telescope when I was in high school. And I actually ground the mirror, illuminized it, and I still have it, and I still use it. So after I finished high school, I actually decided to leave for the University of Arizona in Tucson. It is the main astronomy university in the US. I didn't actually major in astronomy because there aren't that many jobs in astronomy. You basically do the same coursework as you would do for a physics degree. So my advisor said, get the physics degree and there'll be a lot more openings for you for jobs. While I was in Tucson, got to know all the grad students, and I tagged along to all the major observatories there. Got to observe on the 4-meter Mayall telescope up at Kitt Peak. Kitt Peak is actually the premier US observing mountain, has a lot of telescopes up there. There was also the multiple mirror telescope that was near Tucson. Another facility was on Mount Lemmon. There's just a lot of telescopes in Tucson, and it was great being there. I decided not to go into astronomy. I was very interested, it turned out, more in the equipment and the mirrors. So I ended up going to get my master's and PhD of all things in electrical engineering, and that went into microelectronics. And I actually ended up working in Silicon Valley and in Sweden doing photolithography. And then I was building disk drives up at Seagate in Minnesota. But I have off and on worked with and for NASA. I'm back to polishing metal mirrors for them. And one of the most interesting things about me is I actually dated a guy at the University of Arizona who became a Nobel Prize winner. And that's Brian Schmidt. Don't know if you guys were paying attention, but back in 2011, the Nobel Prize went to the 3 scientists that realized that the universe is not just expanding, but it's accelerating. And they had done measurements, and actually both teams that ended up winning the Nobel Prize, their values matched, which gave more credence. So in the middle is a picture back in college. Here's me and here's Brian. And then here's Brian winning the Nobel Prize. So it was quite exciting to end up knowing somebody that won a Nobel Prize. So now let's go on to looking at the night sky. How do I observe it? You have a couple different choices for looking at the night sky. You can use your eyes. You can use binoculars. You guys might have binoculars if you're at all interested in looking at birds. Maybe we can use those binoculars to look at the night sky. We'll have to look and see in my chart. And then there are telescopes. Telescopes cost a lot more money, so you need to really think about whether or not you want to make the for a telescope. So let's look at a little comparison of these 3 techniques. So we have naked eye, binoculars, and telescopes. And the qualities that I'm looking at are basically, what can you see? What's the limiting magnitude of the star that you can see? How faint can you see something? The cost, the ease of use, which determines whether or not you're going to do it. And then what is it that you can see? So with your naked eye, most of us can see to about 6th magnitude. If you have really exceptional vision and you're probably an airplane pilot, then you might be able to see down to 7.8. Our ability to resolve goes down as we age, unfortunately. But it's free. You just have to go outside. It's super easy. If you're in a really dark sky, you can actually see quite a bit. It can almost be confusing because you see so many stars. When you're in the suburbs of Chicago, like we are, you can see some objects, not as much as you used to be able to see, and I'll actually be talking about that. With binoculars, you can see much fainter objects. So these are just 2 different types of binoculars. This is how you would, talk about the binoculars. Basically, you just look at this as being an 8x magnification or a 20x magnification. And if you have an 8x, you can see to about 9.5. And if you had 20x binoculars, you can see down to 10.8, which is pretty good. Now, if you're holding binoculars by hand, though, and like most of us, I mean, we're shaking when we do that. It's very difficult to hold it very, very steady. And then the stars start to dance around. That does affect what we can see. So down here, I say that if you're holding them by hand, it actually goes down to about an 8.5 magnitude that you can see. If you're using one eye versus 2 eyes when you're looking through binoculars, I happen to have this weirdism because I've used microscopes for so long. I tend to use one eye when I look through binoculars. But if you use 2 eyes, you actually get depth of field. You can actually see a lot more. And of course, the cost, it depends on how much you want to pay, which, it depends on what brand you're buying and how good the optics are. It all comes down to the optics. The ease of use, basically for astronomy, to do any sort of observations, you really need a mount. And so that makes it a little bit more difficult because you have to have something that you can easily put on that mount when you're standing in the dark. What you can see, though, is a lot more than what you saw with your naked eye. And so, that is something you might want to think about. Telescopes are a whole nother category. For a 6-inch diameter, like what I have that I made, I can see 12 to 13 magnitude stars. Price on purchase telescopes can vary widely. I mean, you can pay from 400 to thousands of dollars, and some people do. You have to choose something that's easy to set up, and especially if you're going to go to a dark site, you're not going to take something that you're going to be standing in the dark trying to figure out how to put it together. It's kind of like tent together when it's raining and you're in the it's cold. But when you have a telescope, boy, can you see a lot. Galaxies, nebula, globular clusters. That's really the reason people get telescopes, is because they want to see those deep sky objects. So if we just look at some binoculars that are popular for sky watchers, again, like I said, the first number that you would see is the magnification. So if somebody says they have 8x40s, that's an 8x magnification. And the second number is just crazy enough. It's actually the diameter of the front lens on the binocular. And that determines how many photons can get in, because the bigger it is, the more photons can come in. So if you're starting out in trying to do some astronomical observations, most people say 7x50 is a good starting place, and they can be relatively cheap, $50 to $160. So this information is from space.com. It's an excellent place to get information on, what you can use for doing cheap astronomical observing. Now, if you'd like to go to some of the clubs in the area, we have lots of organizations in the Chicagoland area. We have, of course, the Adler Planetarium. That is just a premier facility. Lots of people there that you can talk to about getting telescopes as well. And they just got a brand new telescope just before COVID, so nobody's actually been able to see it. It's a 24-inch diameter, top of the line telescope. Then also I have three of the clubs in the area. There's the Fox Valley Astronomical Club, the Naperville Club, which I'm in, and then the Chicago Astronomical Association. And this is a very interesting association. This is one of the first astronomical associations in the whole country. The famous astronomers from America would all go to the Chicago Astronomical Association meetings. And that's often where they would talk about their new, not just observations, but, what they found. A lot of history in that club. Northwestern up in Evanston, they have a telescope. They do public nights. And then also Elburn School District. This is really fascinating. I had not known about this for the longest time. They used to have the old Elgin watch factory up there. I should have known about this because my father actually had a degree in horology. He was a watchmaker. And I remember him getting boxes from Elgin, Illinois. But up there, there's a planetarium, and they have a transit instrument. And the transit instrument was put in order to get precise timings from the stars as they would move past a line in the telescope field of view. And this was also for the railroad. So the railroad needed to keep really good timing. And that is why the this is why the Elgin watch factory is in Elgin, is because the trains went through there. So I highly recommend, if you ever get a chance, to go up there and see that. Now let's talk about some things that you can observe with your unaided eyes or with binoculars. The moon, that's the most obvious one, right? It's easy to find. It's big, it's bright. You can't miss it, right? You can use your eyes, you can use binoculars. It's really a great object to learn on because you're looking at geological history. I mean, there's all these craters on the moon because it doesn't have an atmosphere. You can see the mare, these dark areas that at one point had water in them. There's also this terminator line, which I don't think people really spend much time looking at this, But when the sun is coming in and hitting the mountains along this terminator line, they become far more obvious. The shadowing, you can see a lot more of the valleys, and you can see the peaks. It's almost like it frosts it with the light, and it becomes a lot more three-dimensional to you when you look in there. So the moon, that's a good one. But we're really lucky because now in this month of May, we're going to have a partial lunar eclipse on the 26th of May. So in the early hours, we're talking around 3, 4 o'clock in the morning. And I know all you wannabe astronomers are going to be up at those hours. We're going to actually get a chance to see a partial lunar eclipse. And so this is a picture of the world put out on a flat surface. And what these different shaded areas show is where the shadow of the Earth will be cast upon the moon during this lunar eclipse. Now, we're not going to be able to see the full eclipse. Here's the red star showing where Chicago is. But what we will see is a partial eclipse. So let's look at that. So if we all know what the geometry is, why this even happens, we have the sun up in the sky. Here's the Earth. And when the Earth gets in between the sun and the moon, between the sun and the moon, the Earth is going to cast a shadow on the moon. But it's not just a single shadow, okay? Because the sun is so close to us, it actually is not a point source. It's actually got width to it. So the light rays that come out of the sun at this side of it come out and come this way. And from this side, on the other side of the sun, the full diameter over, is going to come in this way. And so you actually get the penumbra, which is this very light shadow. And then you get what we would normally think of as a shadow called the umbra, shown right here. And so these 1, 2, 3, and then 4, unfortunately, is underneath here. But what's going to happen, we have here, these lines here are showing as the shadow of the Earth is going to be moving in towards the moon. So here's the full moon sitting there. And then here's where the penumbra shadow will first start. So here's this outer part right here. That's this line here. And it's going to start moving in, and then it's going to touch the edge of the moon. And of course, this is going to still keep moving across as time goes through on that Thursday morning. And then the penumbra is going to move across the moon. So you'll see it very slightly darken. But then here's the umbra coming in. This is the main shadow. And then as this starts to come across, you're going to see the moon darken completely. Now we're only going to see, I think it's about 40% that we're going to see, but it's going to turn red. And the reason it's going to turn red, this isn't going to be a dark shadow, it's actually going to be red, is because the sunlight, as it goes through the Earth's atmosphere, is going to be refracted to longer wavelengths, which is red. And that's why in the evening, our sky, when the sun is setting, is red. So what's happening here is this is going to be red. Blood, not quite, I know people say blood red, it's not like blood red, but it's going to be very obvious. So this is something to take a look at. And then if you want to know what the exact times are, you can jot these down. So this is when the penumbral eclipse will start here, 3:47. And then the partial eclipse will start at 4:44. And then you can see here they've colored this in so it shows the reddening. And this will actually happen then at 5:23. Now this is in the morning, so you got to remember now the sun is going to be coming up and the moon is going to be setting. So you'll see this, it'll be low to the horizon, very low to the horizon, but you can definitely see it because the moon's so big, it's a full moon. So this is something you should, try to take a look at on Thursday morning. It's a really nice way to bring in the springtime, be watching something as beautiful as a partial lunar eclipse. So let's talk about some of the spring constellations that we can see. So now that we're in spring, the dominant winter constellation, which is Orion the Hunter, he's now setting. He's along the horizon when it starts to get dark. So now there's a new dominant spring constellation, and that's Ursa Major. And that means Big Bear, the Big Bear. Now, a lot of people will look at that constellation and they'll see the Big Dipper and they'll want to call that constellation the Big Dipper, but it isn't the Big Dipper constellation. It's Ursa Major, which is the constellation. And I have a picture of this to show you that. So this is very obvious. It's at the zenith, which is looking directly up at night. The other ones that are going to be visible are Lynx, Leo, Coma Berenices, Gemini, and Cancer. And we'll talk about some really neat things you can see in these constellations. Back to the Big Dipper. I really like the Big Dipper. It's easy to find, and there's a really cool little double star system that's in the handle of the Big Dipper. And the two stars are Mizar and Alcor, and they have a little history to them, and I'll tell you about the little story in the next slide. But there's also planets visible this week in the western skies. We can see Mars, Mercury, and Venus. And actually about 2 weekends ago, I was looking at Mars and I was waving to Perseverance. And Mars is very obvious. You can actually see the reddishness to it. And it's in the western sky. And I have some pictures of that to help find that for you. Oh, but let's first talk about astronomy phone apps. Everybody's got their phone with them nowadays, right? So instead of using the old type of thing where we use what's called a planiscope, and I'll show you a picture of that, we now have our phones with us, and so we run these apps. I actually use the Starwalk 2. It's a free app that you can bring onto your phone. And the neat thing about it is you walk around with it and you have to tell it your location. And I think it also reads the GPS so it knows where you are if you're traveling. But it can tell you what constellations are above the horizon in the direction you're looking with the phone. Very handy. So when I was looking at Mars 2 weeks ago, that was how I found it, because I saw Castor and Pollux, the two main stars in Gemini, and I happened to be looking at my phone, and lo and behold, Mars was right there, and I was able to find Mars. There's some other apps over here that are also very popular. You can see a lot of these get 5-star ratings. So these are ones, most of these are free too. So they're really nice to have on your phone in case you find yourself out camping and you want to take a look. So this planisphere is what we used to use in the old days. And it was actually like on a piece of cardboard, and you would have to take it out with you and you would hold it upward so that you could then try to figure out where things were. Sky and Telescope. This is one of the premier magazines for astronomy in the US. It's been around for, I don't know, 80 years or something. They're very well thought of, but on their website, they have this really nice little software package that you can run. You can put in your zip code and the day you want to be looking at something, and it'll show you, like in this case, this is facing west. It's showing you what constellations are going to be out. But if we look over at the planisphere, this is nice because say you want to go out and look at multiple things, you can sit in your house and look at this and say, okay, I know the Big Dipper's up, but what else is nearby? And so this lets you see everything very quickly. Right here, I want to point out, this is the Big Dipper, right? Oh, the Big Dipper, I just said not to say that. This is Ursa Major, the bear, and you can actually see the bear. Here's the bear's tail, here's his little legs, and then here's his snout. And then within Ursa Major, you can see the Big Dipper right here, right? Here's the ladle, and then here's the little cup that fills with water. So what we used to have to do in the old days is we would look at this and we'd say, okay, so I found the Big Dipper, that was easy. So now what I can do is I can take the arc and arc over to Arcturus, and then I can spike down to Spica. And this was a way that you could move around in the sky using the very bright stars that were available in order to get around to different constellations. And I think you guys all know too, that if you use the Big Dipper and you go straight up from the front, you go right to the North Star. So this is Polaris right here, the North Star. And over here, since this is actually, this image here is set up for, this was done on May 11th yesterday. So here you can see Mars. And I was telling you that I was looking at Castor and Pollux. There are these two bright stars here in the constellation Gemini. And of course, Gemini is one of the zodiac signs, and that's for May and June. And so we're in May now. And so here's Gemini with Castor and Pollux, and Mars is visible this very close to Castor and Pollux. And then this for the timing, this is for the 2100 hours. So this is at 9 o'clock. So you can go ahead and depending on what time you're going outside, you can put in whatever it is. And then this will tell you where you need to look in order to see Mars. So let's talk a little bit about Alcor and Mizar. There's a little story about this double star system. So if you notice here, this is the Big Dipper right here. And each one of the stars actually has a name. These are Arabic names. In Arabia, it was one of the greatest educational areas for astronomy. A lot of our astronomy and the algebra all came from Arabia, and that's why these names persist. So here's Alcor and Mizar. Here they're showing them very close together. But back in the old days, when you wanted to find yourself a good shepherd who would be out there herding your sheep, it was really hard to know whether or not they were going to be able to resolve two sheep at 1,000 feet away, because you don't want to lose your sheep out on the hillside. So what they would do as a test is they would tell, oftentimes it was a teenager because they had good eyesight, they'd say, tell me which star is the double star, and then tell me where, using a clock system is, like this is at 11 o'clock, Alcor is at about 11 o'clock relative to Mizar. And that's how you knew whether the person really had good vision or not. So one other thing I wanted to teach you, if you go out to look at the night sky, this is the Big Dipper again. This is an actual photograph of the Big Dipper. And one thing, when I first started looking at constellations, for some reason, I used to think constellations were going to be very small in the sky. I don't know where I got that idea, but I thought they're going to be small. They're not. They are very expansive across the sky. So you have to be looking for large scale, patterns that make up the constellations. Now, one way that people in astronomy get a feel for that, because you can't really take a ruler and things like that. So if you take your fist and you put it at arm's length from yourself and you hold it up to the night sky, the width of your fist is approximately 10 degrees, which is actually the width between the two top stars of the Big Dipper. And then on the side here of the Dipper, this is approximately 5 degrees. So sometimes when you're talking to someone, they say, oh, Mars is about 10 degrees away from Castor and Pollux. Well, once you find Castor and Pollux, you just have to put your fist up there, and then you know about the distance you need to look over in order to find Mars. So this is a really handy little thing that people in astronomy use. So here is Castor and Pollux in the constellation Gemini. This is just a drawing. And so Pollux is very yellow colored star, and Castor is a very bright blue star. You can actually see that. Castor is a very young star because it's blue. Blue stars are younger and burning hotter. And in this constellation of Gemini, one way to remember that this star is Castor is because Castor, if you look down at his foot, he's wearing a cast on his foot. So if we go from here over to the constellation Cancer, which really doesn't look like very much. Cancer is the crab, but it's really hard to see a crab in this, I've always felt. But in this constellation is a visible, what's called a cluster, a globular cluster of stars called the Beehive Cluster. And this blue dot is just to show that there's, an object there. But I have a picture here. This is what the Beehive Cluster would look like. So it's not a really tight, type of a grouping of the stars. They're actually kind of spaced out a little bit. They all are blue like this. Oh, you can kind of see that. And we think that they are related because they're all about the same age, because they're blue, they're hot, they're young stars in this little cluster. And if you're in a really, really dark spot, you should be able to see this naked eye. It'd be totally easy to see this with binoculars if you have binoculars. So now let's talk about some planets. So actually, after I finish this talk, and then as it starts to get dark, so what we're looking at here is a little diagram showing that Venus, Mercury, and Mars are all visible, okay? And what these dates here are showing are actually the phases of the moon. So if you go out tonight, you will see the crescent moon this close to Venus, and then you would see Mercury, and then you would see Mars up here. Capella and Sirius are two very, very bright stars, which are probably the only ones you might see at dusk with this, light level of, in the sky, because only the brightest stars are going to be visible when it's dusk. And then on May 16th at dusk, again, looking to the west, northwest, here's Venus, Mercury, and Mars. And then we're going to have three other very, very bright stars visible. Beetlejuice, I love saying that, Beetlejuice, Procyon, and Capella. Okay, they form a triangle. So a lot of times you might be able to spot this triangle first, and then you might be able to say, oh, okay, I see Venus. And then if you put your fist up, you can then say, okay, about 10 degrees away, is that where Mercury is? And then this looks like this might be about 20, 25 degrees away would be where Mars was. So this would be something very, very beautiful to see in the night sky on the 16th. Now, these are all just images, right? These are like, I used to look at these and say, well, yeah, sure, you just drew that. Of course it looks great. What does it look like if I was really standing out there? I found this really beautiful picture on the Skywatcher website. And this is what it could look like if you went out at dusk. See, it doesn't have to be completely dark, right? You can still see this is dusk because the moon's shining because the sunlight's hitting it, right? So you can actually even see here that there's some lighting on this limb of the moon. You can actually make out the full, object of the moon. I just think this is so beautiful when you see it like this. And then up here, this is actually a photo where this showed Venus. So Venus is extremely bright just because it's so close to us and it's relatively large. It's like the Earth's twin, right? It's like our sister. It's very similar in diameter to the Earth. So it looks quite big in the night sky. So there are many, many resources for finding out what's in the night sky. There's a really great radio show program that comes on. I usually hear this on the radio station out of WNIU because I'm out here in the suburbs. Stardate.org. They usually played around noon and then around 5 o'clock. And you can also go to their website and listen to the radio feature as well. And then there's a whole bunch of just different websites that are telling you what's coming up in the night sky, earthsky.org, timeanddate.com, Sky and Telescope, even companies like High Point Scientific, they make really great telescopes. They do a the sky this month that you can download or get an email. McDonald Observatory is at University of Texas, and they put out an excellent newsletter every month telling you what you can see. So there's so much that you can enjoy in the night sky, especially as it starts to warm up here. It's something where you can just go back, sit on your back deck and look up, you know, see what's out there. Now comes the other half of my talk, where I want to talk about some threats to this beautiful night sky that we all own. The night sky belongs to everybody, and there are threats to it right now. And one of them, I used to say this was the major one, but I'm thinking the second one I'm going to tell you about tonight is the major one now. But light pollution is still a huge problem. Artificial light is a pollutant, and it is not only causing the night sky to disappear for us, but it's also disrupting wildlife. It's affecting our health, the waste of money and energy. People that grew up in the 70s, remember we used to hear about energy conservation, turn those lights out. This was just really awful. Light pollution is increasing at twice the rate of population growth, and 83% of the global population lives under a light polluted sky. So what exactly does that mean? You might say, well, I'm out in the suburbs. It's not too bad in Wheaton. It's not too bad. You're out in Yorkville. It should be great, right? Well, let's take a look. I found this online and I thought this was an excellent way to show what's happening to the night sky. So there are these 5 different locations here: inner city sky, city sky, suburban sky, rural sky, like you're on a farm, or if you're in a dark sky site. This is at the exact same time of the evening, and this is what you would see. So let's say you're in downtown Chicago. I mean, look at the number of stars you might see. I bet you couldn't even see the Big Dipper down there. You know, you start getting out here to the suburbs, you think, oh, I can see things out here. Not really. Rural sky, that's what we have out here. Like say, as you go out towards DeKalb, you see a little bit more, but it's amazing. Until you've actually seen the night sky in a dark sky area, you don't really understand how it's being hidden from you. You're just not enjoying what used to be out there. And if you think of the old days when people used to sit around and they didn't have TV and radio and phones, right? What do? They made up the stories about the constellations and what they saw in the night sky. And this is really, really beautiful. When I was out in Tucson, it was just absolutely spectacular to see that sky. So have any of you guys seen the Milky Way? You might say, well, probably, maybe, I think I did. Well, you wouldn't hesitate. If you actually really did see the Milky Way, you would know it, because it is spectacular. It is absolutely spectacular. It looks just like this. When I was graduating from the University of Arizona, my mother and my brother came out from Washington, D.C. and took them down to Nogales along the border. And we were coming back, and there are a lot of pecan groves that are down there. And I had gone with friends to observe in the pecan groves. So I turned into the pecan groves. My mom got really nervous because she was from Washington, D.C. And she said, where are you going? Where are you going? It's dark out here. We can't see where we're going. And I said, just want you to see something. And we got out there and had them get out of the car. And she looked up and she said, oh, it's gotten cloudy. It's going to rain. And I said, oh, that's not clouds. That's the Milky Way. That's the galaxy that you live in. That's the galaxy you live in. And she actually had grown up in Joliet. She went to school at DePaul, and then she moved to Washington, D.C. And she had never in her life seen the Milky Way. And I'll tell you, she remembered it. And, you know, so she grew up in Joliet. This is a light pollution in Chicago and the surrounding areas. So let me have you focus on this little map. This is Lake Michigan here. This is Chicago and the surrounding suburbs, okay? And what this chart is showing is a little bit busy, but what it's showing is the white areas are on this little graph here, or on this little color coded information. It says for white, basically stars are weak and washed out and reduced to a few hundred. The sky is bright and discolored everywhere. And as this friend or Richard Berry, most people don't look up. Well, why would you? There's nothing to see. So there's just really, we've just destroyed the night sky in the whole Chicagoland area. You really can't see anything. So I don't know, why would you look? Now, there's a group called the International Dark Sky Association, and they started in Tucson, and part of it was originally had to do with astronomy. But as they grew, they've realized that light pollution is a problem for a lot of different things, migrating birds, our circadian clocks. And I went to their website and they had some videos about cities that have really bad light pollution. And unfortunately, downtown Chicago was the one that they ended up making this video about. So let me ask, it's about a 6-minute video. Do I have time for that?
Yeah, but I think so. Please show us.
Okay. Oh, how did that happen? Whoops. Now my little, oh my goodness. Okay, there we go. Sorry. No.
Susan, can you narrate it a little bit as it's going along if the sound isn't working?
Okay, so I thought they basically said it better than, I could, say it. And that was Chicago, right? So like they said, and what I would ask you, what can you do to help? So International Dark Sky Association has on their website these really great ways to reduce the light pollution that we have right now. These nice little cards that you can print out and give to people too. There's also now an approved seal of approval, I should say, for lighting and fixtures that keep light pollution from going up into the sky. And the International Dark Sky Association, if you go to their website, they basically give great talking points, and they give examples that you can use with the public, with your friends, even with your family members. I harass my husband all the time. Simple solutions to fix things. It's really not hard. Turn off the light, get a different fixture, use a different light bulb, use something that's more yellow or red. Doesn't have to be bright blue. Turn off the lights, right? Get involved with the International Dark Sky Association. It it really makes a difference in order to save the night skies for future generations. And if you really don't know, like you have a hard time, like, why is she saying that this is such a problem? Well, there are a couple of places on the planet that are dark sky certified sites. Here in Illinois, we have we have one in Illinois at Dark Sky Park. It's down near Champaign, called the Middle Fork River Forest Preserve. That might be somewhere to go sometime if you want to experience a dark sky and see the Milky Way. There's also one that's not that far away, but it's in Michigan, Southwest Michigan. It's the Lawless Park. The International Dark Sky Association also gives listings of sanctuaries, reserves, as well as communities. For us, the closest dark sky sanctuary is actually up in the Boundary Waters canoe area. It's a very long way to get to that, I must admit, up to the border with Canada. But there are also communities that receive this special stamp of approval if they have done if the municipality has done special things to keep light pollution at bay. And there's 3 near us: Homer Glen, Village of Hawthorne Woods, and Beverly Shores. So kudos to them for doing that work. So that was the first big problem, is light pollution. And then I'm just gonna really quickly touch on this second one. And I want to get you guys thinking about this because I don't know if you've heard about it. And I'm going to ask you, who owns your view of space? Who owns the night sky? Who determines whether or not you can see the constellations in the night sky? Turns out right now, Elon Musk thinks he does. And he actually has the blessing of the FCC for doing that. This week, Elon Musk is actually going to launch another set of 60 Starlink satellites into the into low Earth orbit, which is about 160 miles above. It's not really that far. And he is trying to put these satellites up there to create a basically an internet, a really fast internet coverage of the whole planet. You might not have seen these. These are Starlink satellites being released from the rocket ship. I was actually able to watch this batch. This was on May 24th in 2019. So Elon Musk has been putting these satellites out for a couple years now. There's usually 60 to 66 satellites in each rocket launch. And you might say, oh, those look like cute little lights going across the sky. Well, this is Elon Musk's vision. He's going to put 42,000 Starlink satellites in low Earth orbit above the Earth. These satellites are magnitude 4.5. Remember, we talked early on about what you can see with your naked eye, and we said it was about 6 magnitude. Well, these are 4.5. As the numbers get smaller, the object is brighter. Now, you might remember that he got some flack and he said, oh, well, we'll just paint the satellites so that they're not quite as bright. So he painted some portions of the satellites, and that took it to magnitude 6.1. And I will show you quickly. Here is one of the satellites, and he painted some little sections black, took it to magnitude 6.1, which still naked eye. And the problem is, you might say, well, well, can you just paint it all black? Well, if it was all black, it's going to absorb so much heat from the sun that all the electronics would melt. So he can't do that. It inherently has to be somewhat reflecting in order to reflect the heat and the radiation away from it. So this has gotten into the news recently because there is a beautiful telescope that's being built down in Chile. It was just renamed the Vera Rubin Observatory. This is going to be a 27-foot diameter telescope and state-of-the-art It is going to take a survey of the night sky every night. It's going to generate a huge amount of data, 20 terabytes of data every night. And this is what astronomers were hoping was going to help solve the dark energy and the dark matter questions that have come up. And as you can see in this little title here, a powerful new telescope is about to get screwed by Elon Musk's Starling constellation, research suggests. And if you look at one of the, this isn't the actual Vera Rubin telescope. This is another one that's going to be, is very similar. These are like CCD arrays in here that are all put together in the focal plane. All these lines coming through here, these are Starling satellites just whipping across through the data constantly. And this is only a couple thousand. He wants to put 42,000 up there because Elon wants to cover the whole Earth with these. We're going to have all this. And at low Earth orbit, which is so low, these are very obvious to the naked eye, extremely obvious to the naked eye. So it's not just something with a telescope where you say, oh, you have to be looking for, you know, really far away and all that. No, these are so bright, so very bright. And so it's going to hurt, just the amateur backyard astronomer. You know, you're just going to be looking up and say you decide to go out and look at a beautiful meteor shower, the Perseid meteor shower. And well, how are you going to tell the difference? You got all these satellites just flinging by in front of you. So this isn't the only problem being Elon. Turns out Jeff Bezos of Amazon, well, he's in a little race and he has his own little project. And his is called Project Kuiper. And he's going to be sending about 3,200 satellites up into orbit. Oh, but that's not enough. We have another company called OneWeb that operates out of the UK. And they've already started sending up 687 satellites are up, and they're planning for 6,300 more about to go up. And of course, in the UK, they don't have to get FCC approval because the FCC is just in the United States. So wait a minute, who owns space? Who gets to make the decision about, you know, who gets to put these things up? I would say that if it's going to be up there ruining my view of the night sky, I'd like to have a say in that. You know, 42,000 plus satellites, that's a lot, right? So it turns out too that ground-based radio astronomy is going to completely, it's going to disappear. You won't even be able to do it. And what about other countries? What about China when they start launching? Are we just going to look at a bunch of satellites? Do you care? Do you care what happens in the night sky? Have you know, most people anymore just look at their phones or something, but you know, the night sky is, you know, very much a threat to being completely changed and altered for future generations. So anyway, thanks for your attention. If you have any comments or questions, I welcome them.
Thank you so much. We Mary Lou asked a very good question towards the very end. And Mary Lou, why don't you come off mute and go ahead and ask your question?
Thank you for an interesting presentation. I look forward to the links to the videos that we didn't have audio to. But when you talk about the Starlink satellites, they sound visible now, at least a few thousand of them. How do we and where do we look to see them?
Oh, they're actually now, if you just type into, like, say, Google, type in schedule of Starlink satellites visible, it'll pop up. You'll be able to find it. They'll tell you exactly where you can find them.
That's amazing. Who's in charge of regulating the night sky?
Well, there really isn't. There really isn't. So right now, interestingly enough, it's the FCC that determines about satellites that go up, not NASA. A lot of people get confused. Oh, NASA's deciding that. No, NASA does not decide that. It's the FCC. And, but that of course is just for the United States, right? So we don't really have, we're starting, and I didn't think I was going to see this yet. We're starting to get into a whole new realm of space law, right? Because like Elon also, he wants to go to Mars. Well, who owns Mars, right? Who owns Mars? And actually what I read that all these Starlink satellites and his whole project, he's hoping to make enough money bringing internet to the whole world. That's what he's counting on to fund his Mars adventure. Now it gets it to be a sticky problem here, right? Because, you know, you start getting into debates with people like, but he wants to bring internet to everyone, to Africa, to areas where there isn't any satellite coverage. And he wants to use satellites so that, you know, you have coverage constantly and it's cheap. And there's a lot to be said for that. But, you know, you willing to give up the night sky?
Does anybody else have, this a very, thank you for posing those thoughtful questions to us. I think it's paramount that those who are the big decision makers help us start to consider some of that. Anybody
Yes,
have,
sir.
maybe should we go off, so we can see people's faces? Do you want to go off of the screen?
Yeah.
Screen share?
Yes.
Go ahead, Jeff.
Yeah, I have a quick question. Now I forgot what it was after getting my picture back. But oh yeah, can you put in the chat, Susan, a link for that video that the IDA had?
Yeah.
I think some people want to see it again later.
Well, actually, you know what I was wondering, Jeff? What if I sent you all the links that I
Okay.
have for, you know, the resources for the night sky and then for the light pollution and all that? Because yeah, there are quite a few, and I'll just email you those, and you could send them out to the club.
Yeah, we can forward them to everybody who was registered tonight. Yes.
Okay.
Very good idea.
Great.
That was amazing. Anyway, I see there's a lot of applause going on. I see some applause in the chat. Very nice.
I'm not surprised that some people would just be quiet, because when I first saw the video, I was like, really? This is going on? 48,000 of these things?
You aware that we could hear no volume?
On what?
The video.
Which one?
I've never had had experience with being able to play a video in screen share and have the volume come through. So I think this is not her responsibility.
Oh, no. It's, yeah, no, I just didn't know if you were aware. So during the video, we didn't hear anything.
Wait, on the Starlink satellites?
The one about Chicago, like
Saving the dark. Couldn't hear a thing.
that's why I said, could you maybe narrate a little bit?
I'm sorry.
That's all right. It was
Yeah, well,
good
you'll be
pictures.
able to watch that on the you'll be able to watch that on YouTube. I'll send the link. Yeah. I was a little shocked and dismayed that they used Chicago as the like ultimate evil light pollution city. So, but and basically what it was saying is that, you know, we've so destroyed you know, the circadian rhythms of ourselves, people that work at night, birds fly into buildings, you know, trees are on very odd, you know, times now where because there's so much light, they don't know when it's time to drop their leaves. And the light is so affecting things.
Yeah, you can see in the chat various comments about places that people have gone to see dark skies. And I was just wondering what your favorite place is that's not too far away, where you can at least see something of the Milky Way or your favorite constellations.
So last summer when we had the comet come through, Comet Neo, I went with friends over to Afton State Park. So Afton is just south of 88, I-88, and out towards kind of south of DeKalb, but south of I-88. And the only problem is there are cops that come through, right? So you have to get approval ahead of time to be out there in the dark. Even a couple of our astronomy members are out there with telescopes. Even when I was in Washington, D.C., and I would take my telescope out, I can't tell you how many times the cops would show up and they'd be like, "What are you doing out here?" And I was like, "Seriously? You don't know this is a telescope?" You know? And yeah, you're not allowed to be out in parks and it's dark. Somebody in Wheaton had theirs out and he got called into the cops. Somebody said he had a bazooka. So you have to be careful. But Afton is the closest around here. Now, the other thing, if you ever go on the Mississippi River and you get like one of those, I always forget the name, not a pontoon boat, but a houseboat. And you sit up on the deck. I had my nephew come out from the East Coast and we were up there last summer and it got dark. We were up near like La Crosse on the Mississippi and it was so dark. And he goes, you know, just like my mom would say, he goes, "What are those clouds?" And it's like, "Oh, that's the Milky Way," you know? So anywhere along the upper Mississippi is really good if you're camping. That is really good. And it's, you know, driving distance. Oh, I'm sorry. I wasn't even looking at these. Can you comment on the impact holiday light show at the Arboretum? Oh, that's just over such a short amount of time that it's not a huge problem. Oh yeah, Lake Geneva at Yerkes. Yeah, there's a lot more light up there. But you know what? They saved Yerkes and
I know.
they're gonna try to make it a place where you can bring your telescopes and observe. Let's see, are there acceptable lights one can place around a deck patio or should we remove them entirely? No, and actually when I send those links for the International Dark Sky, there are some excellent ones, but all the light, you know, they're shielded so that the light goes downward. It doesn't need to be like filling up. I don't know if you guys have ever experienced, if you're driving in the fog on the road, if you put on your brights, you can't see. It's even worse. Right? It turns out if you're driving in fog and you actually turn off your headlights and you're just using your parking lights, you can see better because the contrast is lower. The way your eyes work is such that you can see more if there's not as much contrast. You can actually have somebody hiding in the shadows and really strong shadows. They can be in the dark and you can have a huge bright, you know, light. And then all of a sudden they can jump out at you and you didn't see them because the contrast was so strong. Let's gonna look what other questions.
I think we got the lion's share of them.
Oh, Door County. Yeah, that's beautiful up there. And the Boundary Waters has the Northern Lights. That's true. Yep. Yep. And oh yeah, so somebody's been to Death Valley. Yep.
I understand the local group will be, the Naperville Astronomical Association will be having some events eventually. You know,
Yeah.
so
Yes.
historically there were some, at least in Naperville, I mean, the people in that club have the ability to show you things with a telescope, even when it's light polluted. It always amazes me. And even downtown Naperville with street lights and everything.
Yeah, we're out of the
They'll point
water.
the scope at a spot in the sky and say, "Look, there's such and such."
Right. Yeah, we're
It's
at the
amazing.
treatment facility, but yeah, there's a lot of telescopes out there and members bring their telescopes.
Mhm.
One thing, just a little trick, again, it's about your eyeball. When you're looking at something, when you stare directly at it, a lot of times you can't see it. If you use what's called averted vision, where you look just to the side, all of a sudden you can see it. That works for that double star, you know, the Mizar. And if you just look a little off to the side, your averted vision will be able to see it. So it's just the way our eyes also have evolved, that you stare directly at it and it'll just disappear.
We're getting pretty close to 8:30.
Yeah, that's, if there are no other questions or.
I am so excited and that you're going to be sharing these links with Jeff.
Yes.
And pass them on out to the others. And I'm thrilled. This is the good thing of Zoom. We have really nice attendance. We had 43 was the high number during the time that you were speaking. So you really got a lot of interest and a lot of people came out. I'm very, very glad. I hope you'll read your newsletters, folks. There'll be another one coming out June 1st with events that we're working on. And we're so grateful for your membership in Sierra Club and your interest as we all work to protect the environment and environmental justice. Thank you, guys.
Great.
Remember, contact me if you want a phone bank. We're going to get clean energy so we can have a good planet.
Thanks, everybody.
Yeah, thank
you.
you. It's good to hear some voices there. It's okay.